Hi, in this video we're going to take a look at triggers. Triggers are a way of doing event-driven programming in databases. So, for example, if you make an update or a delete, you can automatically trigger certain other actions to follow on from that. So, I'd like to introduce triggers by picking a particular example and working our way through how we might go about implementing a trigger to do this. Okay, so back to the pizza database. Imagine that it's important to know how many varieties of pizza each store sells. Okay, now we've seen in our PLPGSQL video that you can write a function to do that, and here's the function. So it takes in a store ID and returns a count of the number of pizza varieties in that store. And it works out all the information by doing a join. We join stores with suburbs to get the store name, and we join stores with sold in to get the number of, or to get the individual pizzas that are sold there, and then we use a count to count up the total number of pizzas. Okay, so this is going to be done for an individual store. Alright, so let's load this function in. I'll do it this time by copy and paste rather than loading from a file, so we can just copy and paste, and we've created a function. So if I happen to know that there's a store number 100, I can find out how many varieties of pizzas it sells simply by doing that. And this tells me that store 100 sells 24 different varieties of pizzas. Okay, that's nice. Kind of doesn't help me so much because I have to know the store IDs to work this out. So let's go back and consider a few more aspects of this problem. Anyway, hopefully that function is clear enough. Given a store ID, return a count of the number of pizzas that store sells. So, given that function, it wouldn't be too hard to write a view that runs through the stores, joins with the suburbs to grab the suburb name, and gives us the name followed by the number of varieties of pizza at that store, worked out using the function that we just saw. So straightforward query. For each store we have to compute the number of varieties by going back and doing all of the computation that we saw in the previous example. So let's give that one a run. Back into the pizza database, copy and paste in the view, and then look at all of the tuples in that view. Okay, so Sydney City sells 22 varieties of pizzas, Surrey Hills sells 27, and so on and so on. Okay, so we've got the store information, or as much as we want, and we've got the count of the number of varieties of pizza in that store. Okay, let's go back to our example. So this version of store info has to recompute the number of varieties for each store that it finds during this join. Now that's not super efficient, and it would be much more efficient if we actually stored the number of varieties of pizzas in the store tuple itself. So then it would be very easy. We wouldn't need to invoke the nVarieties query each time. We could simply look it up, look up the count in the store tuple. Okay, so this part of the query is the same as above. The difference is that rather than having to do a function call, and if you remember, the function actually does something like the query that we were just doing, with a little bit of extra work on top of that. Even if it didn't, it would still be relatively expensive to call a function for each tuple as opposed to just looking up a value. Alright, so what can we do about that? Well, it would be possible at the moment, if we go and look at the store table, there's no varieties column, so no counter for the number of varieties. And that's kind of reasonable because storing that is a little bit redundant given the fact that you can count the number of varieties as we did here. Also, if we manage to count the number of varieties once, then if it changes, if we add or delete a variety from a particular store, we have to make sure that we update the count of the number of varieties that's actually in the store tuple. So let's press on and try to do this efficiently. So one thing we could do, we could add the varieties column to the stores table. Okay, so this is using the alter table functionality, and that adds a new column to the stores table. So if we wanted to, we can go select from stores, and one thing that we're going to see is that there's nothing in this column. It couldn't work out how many varieties there were. It's not kind of obvious. In fact, all we really asked for was a new integer column. We didn't say how that was supposed to be worked out. Alright, so we've got an empty column. What can we do about that? Well, conveniently, we've got something that will count the number of varieties. So we can actually run through this table, update the stores table, and set varieties to be equal to the number of varieties that we count using the function and given the store ID. So that will run through the table and update the counters. So if we go back and now we run this query, then we've got the number of varieties. So as I mentioned before, that's all very nice, while the offerings at each store doesn't change. If a store adds a variety or removes a variety, then we have to remember to go and update this. Now, having to remember to do something is fraught with the possibility that you might forget. So it'd be better if we could do it automatically, and of course that's where triggers come in. So if we can set things up so that whenever we add a tuple to the sold in table, then we update the varieties counter for the appropriate store. So when we add a tuple, we're going to say this store sells this particular type of pizza. And so we know what the store is, we know that there's one more pizza, so what the trigger would then have to go and do is update this counter. Similarly, if we delete a pizza, or if a store stops selling a particular variety, then we've got to reduce this number. So there'll be a delete operation. If there is a delete operation on the sold in table, then we need to go and reduce the count for the particular store. So that's where triggers come in. So let's go and take a look at a trigger that might do this. Alright, so this trigger I'm going to call maintain the variety count, if you like, is going to be invoked after each insert or delete on the sold in table. We assume that we're not going to do updates on the sold in table. So you either add a new variety of pizza or you remove one of the existing varieties. So events on the sold in table will cause this trigger to be activated. Okay, for each row basically means if you happen to do an insert or a delete that removes multiple tables, then we're going to make sure that we calculate the new values for each of the modified stores, in fact. So if we delete multiple sold-in tuples, then we're going to get the correct value for the number of varieties in the stores table. And how do we achieve this? Well, we execute a trigger function called change varieties. Okay, one thing to remember is that this trigger function is going to be invoked either after an insert or after a delete. Now, the fact that it's invoked afterwards means that we've done all of the various constraint checking. We're not trying to insert an invalid pizza or using an invalid store ID, or we're not trying to delete an invalid pizza or from a non-existent store. So all of that checking's been done. We know that the insert or delete is actually going to happen. So then what we need to do is maintain the varieties count. So now let's go and take a look at the change varieties function. Alright, what do we notice about it? Well, one thing to notice, it's a function that returns a value of type trigger. Now basically that's just Postgres, a special Postgres return type to indicate trigger function. So all trigger functions return this type. Other thing to notice, the function doesn't have any parameters, so it just gets invoked, and therefore it's going to have to work out what the situation is so that it can take the appropriate action. Alright, well, when you get inside a trigger function, there are a number of things that are predefined. One of the things that's predefined is the type of operation that got you in there. So tg_op is trigger operation, what invoked the trigger, and we can check whether it's either insert or whether it's delete. And they're the only possibilities, or they should be the only possibilities, given that the trigger is invoked after insert or delete. The other things that are available inside the trigger function are the values of the new and old versions of a tuple. So if we're doing an insert, clearly the new tuple is going to have, the new tuple that we've just inserted is going to have to contain a store value. And similarly, if we delete a tuple, then that tuple contained a store value. Now if you're doing an insert, there's only a new tuple. If you're doing a delete, there's only an old tuple. If you're doing an update, you get the new version and the old version both available. But here we're not doing updates, we're just doing inserts and deletes. So if we insert a new tuple into the sold-in table, that will invoke this triggers function. It will check, it'll see that it was an insert operation, and then it will execute this statement. You can see that this statement goes to the stores table for the corresponding store, the store mentioned in the new tuple for which a new variety has been added, and then increments the varieties count by 1. Similarly, if you're doing a deletion, then you go and you delete you reduce the varieties count by 1 for the store that's mentioned in the tuple that's just been deleted. So they're the two possible valid actions that can happen for a trigger function. If the trigger function is invoked for some other operation rather than either insert or delete, then we're going to complain and we're going to raise an exception. This is actually going to cause the update to fail. So raising an exception is built-in Postgres functionality. The argument to the exception is a string, and that message will be printed on the output of PSQL if you're running through PSQL, or else it'll be sent to the database log if you're not running through PSQL, if it's been invoked some other way. The other thing that trigger functions have to do, they have to return a value. In the case of this particular trigger function, because it's happening after the insert or delete has happened, there's not really much point in returning anything, because hopefully the update operation has made the appropriate changes to the database to be consistent with the update or delete, with the insert or delete that's actually happened. A reason where you might want to return something other than null, for example, if you've got a before trigger and the before trigger does some checking, and if it discovers that there's something funny with the tuple and perhaps it can recover from that, it can actually change the values stored in the new tuple and then return new at this point, and that would become the tuple that actually gets inserted into the database. So you could actually take a tuple that the user has requested to be inserted and actually make changes to it before you add it to the database. Alright, so hopefully that's enough of a description of what's going on here. We've got a trigger function that operates on insert or delete. Let's see whether it works. Okay, so let's go to the pizza database and load up the trigger and the associated trigger function from that file. Okay, in pizzas. So we load it, we get a notice that the trigger didn't exist because we tried to drop it before loading it. Unfortunately, one thing to notice, the functions that the trigger uses have to exist before the trigger can be defined. So those definitions in that file are actually in the wrong order. I can simply go and grab the trigger definitions. Now the trigger wasn't actually defined, so I should just be able to create it now that the change varieties function has been inserted in the database. Okay, so now I've got the trigger and I've got the trigger function. Alright, how do we know if it's actually going to do something correctly? Well, one thing we could do is, let's say for the sake of argument, from... Okay, so store... We don't know the suburb at 24 varieties. I guess if we wanted to, we could go and check that. So select from the sold in function where the store is 100. And it helps if you spell the keywords correctly. Okay, so there we are. So there are all the pizzas that are sold, and good to see there's 24 of them, and the value in the stores function is also 24. Okay, so what we want to do is delete one of those pizzas, and let's say for the sake of argument that we get rid of pizza number 20 or pizza type 28. So delete the tuple in the sold in function that tells us that pizza 28 is sold in store 100. Okay, so we've deleted that. Now if the trigger is working correctly, then what should have happened is that the in varieties function should have been reduced to 23, the in varieties attribute. So we didn't touch it. All we did was delete a tuple from the sold in table, and hopefully that's had an effect on the stores table. And we can see that it has. So because we removed pizza type 28 from store 100, there are now only 23 varieties. And if we wanted to go and check that, we could. And if we wanted to go and check that, we'd see that there are now 23 rows and pizza number 28 is missing. Alright, well let's add it back. We've only tested half the functionality of the trigger. So if we insert into the sold in table, let's add back pizza 29 into store 100, sold for around $10. That'll do. So there is no such pizza as 29. Good. So all of the constraint checking is happening. So an interesting point, because that insert failed, we would hope that the varieties count hasn't been updated. So we see the insert failed, there was nothing inserted into the database, so the trigger didn't happen, and so that wasn't updated. Alright, well, let's try that. Don't try to be clever, just use a known pizza and add that back in. Obviously we change the price of the pizza if you were watching carefully. Okay, so now we should see that once again there are 24 pizza varieties sold there. So that's a simple example of using a trigger. Remember, triggers are effectively event-driven programming on the database. Some common usages are the one we just saw, actually, to maintain summary columns. Another common use for triggers is to do more complex constraint checking than Postgres's constraint checking by itself will provide. Okay, so that's it for triggers from me. There are some activities that you should do to get a little bit more practice with triggers. Okay.